Welcome to The Explainer. Today we're going to dive into the surprisingly fascinating world of an unsung mechanical hero, the bevel gear. Yeah, it's a component you rely on literally every single day, even if you've never actually laid eyes on one. Okay, so let me ask you something. Have you ever really thought about what happens when you turn a corner in your car? I mean, the outside wheel has to travel a longer distance, right? So it has to spin faster than the inside wheel. How does that even work without the whole thing just, I don't know, grinding to a halt or breaking? Well, the answer is some truly brilliant engineering. It's a secret that cars have been using for over 100 years. And the magic, it all happens deep inside the axle. It's hidden away in a clever little device you've probably heard of, but maybe don't know exactly what it does. It's called a differential, and that is the mechanism that lets the wheels spin at different speeds. So right at the heart of that differential, that's where we find the hero of our story today. So let's meet the bevel gear. Okay, so what is a bevel gear? Well, at its core, it's basically a gear that's shaped like a cone. Its main job is to take rotational power from one shaft and send it over to another one, usually changing the direction by 90 degrees. You could say it's the gear that literally lets motion turn a corner. Now, when you look at a bevel gear setup, you're almost always going to see two main parts. The smaller one, that's usually the one bringing the power in, is called the pinion. And the larger one it's turning, that's just called the gear. It's kind of like a leader and a follower in a little mechanical dance. But here's the thing, not all bevel gears are the same. No way. Depending on the job it needs to do, engineers have come up with a few different designs. So let's start with the most basic one, the foundation of it all, the straight bevel gear. So if you look at the design, you can see the teeth are straight and they taper down towards the point of the cone. This simple shape makes them way easier to manufacture, which is great, but there's a trade-off. When the teeth connect, they engage all at once, clack, which can be pretty noisy. That's why you'll find them mostly in lower speed stuff, where a bit of noise really isn't a big deal. Okay, so that's the basic model, but how do you make it better? How do you improve on that simple design? Well, that brings us to a more advanced version, the spiral bevel gear. And this is a huge leap forward. Instead of straight teeth, these are curved. What does that do? It lets them engage gradually, smoothly. It's like a perfect rolling handshake instead of a high five. And because of that smooth, gradual contact, they're way quieter, much stronger, and can handle a lot more load and higher speeds. All right, and that brings us to the specialist of the group. This is a type of gear that is just absolutely crucial for the automotive world. Meet the hypoid bevel gear. Now here's the key difference, and it's a big one. Unlike the other two, the shafts for hypoid gears don't actually intersect. One is slightly offset from the other. And this really unique geometry means there's even more tooth contact between the gears. That allows them to handle the incredible torque you find in the rear axles of cars and trucks. Yep, this is the gear that's doing the heavy lifting in your car's differential. Okay, so let's do a quick recap here. You've got straight gears, simple, good for low speed. You've got spiral gears, the smooth, quiet choice for high loads. And then you have hypoid gears, the offset, high-torque champions of the car world. See? Each one is a specific tool for a specific job. All right, so now that we know the different types, let's go on a little safari and see where we can find these gears out in the wild. And trust me, they are everywhere, not just in cars. You know that right-angle head on your power drill? Yep, that's a bevel gear turning the power 90 degrees. What about those gigantic fans on industrial cooling towers? They're spun by massive bevel gears. They're even in helicopters, redirecting the engine's power to the main rotor. And in the powerful drives of ships. They're amazing. So why? What is it about this simple cone shape that makes it so effective and so enduring in the world of engineering? Let's break down the real power of the cone. It really all boils down to three main things. First up, flexibility. We've talked a lot about 90 degrees, but they can actually be designed for all sorts of different angles. Second, durability. Their design is just naturally tough, which makes them perfect for heavy-duty work. And finally, efficiency. Man, are they good at transmitting power without losing much energy along the way? And when I say efficient, I don't mean just pretty good. I mean exceptionally efficient. Get this. Under the right conditions, a bevel gear system can hit up to 99.5% efficiency. That is just an incredibly tiny amount of energy being wasted. It's amazing. But, and this is a big but, getting that kind of performance requires incredible precision. It really highlights a key rule in engineering.
You can't just grab any two bevel gears and stick them together. They are designed, built, and installed in matched pairs to make absolutely sure those teeth mesh perfectly. That's the only way to get that smooth, efficient, and long-lasting performance.
So there you have it. From solving that tricky problem of a turning car to powering the tools in your own garage, the bevel gear is just a fantastic example of ingenious, elegant design. It kind of makes you wonder, doesn't it? What other hidden gears are out there, silently and perfectly powering your world?